engineering videos and technical solutions, BTech and Master Engineering thesis guidance, simulation of projects using different software such as MATLAB, PVSys, Helioscope, ETAP, and many more. Detailed videos on these topics and much more available software such as AutoCAD, Revit, and SketchUp. Be part of our family by subscribing to our YouTube channel, follow us on Instagram, like our Facebook page, and visit our website. PZ Engineering, passion to excel.
Hi, welcome to the PZ Engineering channel. In this video, we are going to show how to design and simulate bidirectional DC-DC back and boost converter. This is equivalent circuit of bidirectional DC-DC back and boost converter. From our left to right, it works as a boost mode, and from our right to left, it works as back mode. We have the battery as the main source and the DC bus as the alternator. Here you have our circuit diagram of a boost converter mode. When switch 1 is on and switch 2 is off. Here is our circuit diagram during back converter mode. When switch 2 is on and switch 1 is on. Here are equations we use during the boost mode. You have a duty cycle, the minimum inductor value, and the minimum capacitor value. Here you have equation for back mode, duty cycle, and the minimum inductor value. Now we are going to build and simulate our system in MATLAB Simulink software. We are going to use a manual battery control and automatic battery control, where the battery will supply the current to the load in very first seconds. And after that, the current produced by DC bus or alternator is used to charge the battery. We have our battery, and these are the measurements from that we are going to get from the battery, the state of charge, the current battery, the voltage battery. Now let's build our bidirectional DC-DC back and boost converter. All the components we can get them from library browser. Please be part of our family by subscribing to our channel, share our content, comment, and suggest any topic we can work on. This is our bidirectional DC-DC back and boost converter. Here I have the resistor value, our DC bus voltage should be greater than the maximum charge voltage of the battery. Now let's build our battery control, which will work manually and automatic. Just taking all the possible components that I'll need. I just enable gates. Let's change here to negative. Our reference current. Now we can change the value of our PI controller. Now let's connect our PW. This is the value of switching frequency that we use to calculate the parameters. We are done with the main controller. Now let's build the charging and discharging control. The individual charging and discharging control. Let's put our reference charging voltage. The charging reference voltage must be the same as in DC, that means the same as in DC bars, and as well in the maximum charging voltage. Here we will put the maximum discharging current or the maximum charging current, which our reference is maximum discharging current of the battery. It must be the maximum charging current of that of the put in our PI controller. Let's use negative -1, which shows the negative current, negative charging current. Now let's build our discharging control. Our output reference voltage. This is our switch which we'll use to switch on, to supply, and to charge and to discharge. Let's build our manual switching control. let's build our subsystem to be our control. Let's just open to see if everything's okay. Yeah, seems okay. Let's make our scope. Let's make our build our measurement. Let's connect the switch to our ideal switch in the DC-DC back and boost convert. Now let's check the system for the value that we used and if it's everything okay. Here inductor. Here we didn't change anything in our MOSFET, capacitor, resistor value. We have our DC bus, and there is our measurement, state of charge, the current level, and the current of the battery, and the voltage of the battery. Since okay there, if our gauge, the change to group, yeah, it's the same thing. Now let's get our power grid for us to simulate our system. Now we can simulate our system using manually control. The battery now is applying. The battery now is applying. or it's discharging. Let's change the simulation time. The battery is charging, is discharging, or is applying. Now let's switch on to another mode. It should change. Now the battery is being charged by the DC-DC bars or the alternator. See here, first seconds is by supplying, now it's discharging. The voltage, the voltage, the charging voltage current, the charging voltage reference is going close to 13, and the current is going down to the minus. Now it's minus to the reference charging current that we put. Since our system is working well manually, now let's build our automatic control battery where we don't need to change manually after 3 or 4 seconds. Let's put the battery with supply at this second. Let's connect to the switching. Now we can, here's the value. Now we can simulate our system. The voltage or the battery now is supplying, as we can see. After 3 seconds, now is being charged by the alternator. There we have our voltage, our charging voltage. The voltage is increasing because our charging voltage is greater than the nominal voltage. We have our negative current, and according to our reference, and we have our state of charge is increasing as well. Let's stop the simulation. Let's increase maybe to 10. Yeah, the battery will supply after during 10 seconds, and after 10 seconds the alternator will charge the battery. Let's leave it there. Now the battery is charging. As you can see, the battery is supplying, is discharging, and after 10 seconds it should change where we start the alternate the DC bars will start charging the battery. Now it's charging. The voltage is increasing now to the reference current or to the reference voltage, and the current is going down to the reference charging current. State of charge is going up. See, the voltage is going up, is increasing to the reference charging voltage. You can see it's charging. Let's just maximize our value so that we can see better. You see here, the battery start discharging after certain, and then after 10 seconds the battery start charging. Thank you so much for watching. Please be part of our family by subscribing, share our content, comment and like the video.